Okay, so today we will see with some basic structure of C program as well as the some examples of C programs. Okay, so actually till yesterday we saw about introduction to C language. Actually, in operators side, so we have many types of operators, but to write the demonstration programs or the syllabus what we have. So first five operators. So what we discussed is enough, I think so. Because these first five operators we will come across in the program, so just we will move to the programs. Okay, then if at all if it is required for us to discuss with these with the sixth and seventh operator, then we will come back to these operators. So but with these first five types of operators, it's enough for us to discuss the programs. Okay, now we will go for the programming part. Okay. uh, okay. Okay, so before we go to the C programming part, just let us understand how the entire computer system works. Okay, it's in general, not only with respect to C programming or C++, it's in general. So if you look at this image file, so here, so when we consider the computer system as a whole, so we can divide into four layers here. So first layer is users, that is programmers, and this users even we can consider it as the end users as well as the programmers, one who build the software or write the programs. So then comes the second layer as application programs, that is softwares, we can call it as application softwares or application programs. Third one is the system programs or system software. So software is divided into two main types, system software and application software. So then comes the computer hardware. So finally, whatever the task we do, computer hardware will start working. For example, we type something from the keyboard, it is displayed on the keyboard. So that when we type from the keyboard, so keyboard is the hardware thing, and even monitor is also hardware thing, which displays on the screen. Or if you give print option, so we get printout on the paper. So even that is printer is also hardware device. But so when user interacts with the computer hardware, he will not interact directly. So if you look at this diagram, there are two more layers between those two. Okay, that is between the user and the computer hardware. So one is application software, another one is system software. Okay, or application programs and system program. For example, if you open the MS Word and if you print one page, that is if we want the hard copy. So then also, like see, MS Word is an application software, and for printers we require driver softwares. Or for example, if you listen to the music, there also we require audio drivers. And in addition to this, too, we require one main system software, that is called as operating system, because without operating system none of the computers work. Okay, so now if you look at this diagram, so there is no direct interaction between the user and the computer hardware, but there is an interaction between the application software and the user. For example, if we open MS Word. Okay, MS Word is an application software, and if we open Turbo C editor, okay, C to write C programs. So C, C++, Java, these high level languages are all called application programs. So that means we have the communication with C programs or MS Word, Excel, Internet, browsers, and all. Okay, then this application softwares or programs will have communication with operating system. That means operating system will make these application softwares to work. So unless until operating system is not there in the system, these application softwares will not work. And even we cannot install the application softwares in the system also. Okay, then this operating system, even it has the communication between the computer hardware. Okay, computer hardware and operating system will have the intercommunication. Okay, so from this diagram what we can understand is, whenever user uses the computer or program writes the programs, so he will have the communication with the application programs, and that application softwares or programs will have the communication with the operating system, and that operating system will have the communication between the computer hardware. Now coming to the programming language, so what we are learning now, C program. So C++, Java, HTML, these languages comes in this layer, that is application programs, because by which we can develop some application softwares. Okay, so these softwares or the programming languages will come in this layer. Okay, so when we write a simple program in a C program, even if it contains two or three lines, so this operating system will make the C program to work. So similarly, when we open MS Word, okay, So to open an MS Word operating, we require operating system, because operating system will make that MS Word application to open it. Okay. Similarly, operating system will make C program to open to execute it. Okay. So then comes the operating system. So even if you write the programs in C or C++ or Java, operating system will make the C programs to work. So now let us compare with this right hand side of the image. See, if I write a C program, so this C program is considered as application program. So operating system will make this C program to work. Okay. So if we write a program and if something is displayed on the monitor, so that monitor we can consider it as hardware. So if you look at this operating system, it acts as an interface. So interface meaning the medium, so which is used to communicate between the two. So operating system is a best interface, we can say. So operating system acts as an interface between C program, that is application programs, and also the computer hardware. Okay. So when we write a simple C program also, so if you look at this program we have written, so it's very simple program, that is main function is there, and opening brace and closing brace. So these things we have discussed in character set. Okay, parenthesis, braces. So these flower brackets are called as braces, and this after the word main, whatever the brackets have written, those are called as parentheses. So these are the technical terms, and this main word is a function. So in C programs are written by using functions. So that we will discuss soon, what are functions and all. So if we write this simple program also, what happens is first operating system will give the control to the main function. That means C program should work. So this we have written and we try to execute. Okay. So when we say programs will work means programs will execute. So execute word we have to use. That is the technical term. Or run, we can use the word run. So this run word is used in programs part. That is programming language. So main function or this main program should run, or we can call main function or main program should work or should execute. So if it has to execute means operating system should give control to the main function. Okay. Then after all the work is done by the main program or a function, again the control is returned back to the OS. So this is the functionality of application program. For example, here I open I have opened this MS Word. That means operating system is giving control to this MS Word, that is application software. Now if I close like this, see on the top right corner close icon is there. So if I close, so it will ask for save changes and all. Now it has closed. That means that control, that application software, that control it has given back to the OS. So this is how it works. There is a communication between application programs and operating system. Now here if we consider operating system is giving control to the main function, then main function starts working. That means our C program starts working, it starts executing. After all the work is done, the control is again given back to the operating system. So in this way we can consider how the overall computer system works. So not only with C programs and all, so whenever we go to the any like computer functionalities, so in offices we see clerks will be sitting in front of computers. So in, for example, in hotels we see they give the bill. So wherever we see the computers working, so these four layers we can consider: users, application softwares, system softwares, and computer hardware. In some cases, see for example, those who develop like operating system or those who write system programs, so they will have the communicate as a use. There also programmers will have communication directly with system programs and computer hardware. In that way we can consider. Okay. So now people take down this diagram. So diagram you can take down roughly, and also with respect to C program you take down.
If once they are done, if you can once you can explain on the user, the second block is where the parentheses and closing brackets are used. Part, if you can just explain once again.
Okay, fine. So here,
I couldn't follow it. Let they copy. Yeah, it means it's okay. Let they be copying it.
fine. The one minute. Okay. So others you copy the first block and also the second block. So you just be copying. So we will discuss. So in the second part, so if you compare with the first part, so users, that is end users or the programmers, so one who writes the C programs. Second layer is the application softwares. Okay, so here when we write a C program, we need a turbo C editor or C software. So that software is nothing but a application software. So there we write the program. So this is the smallest program in a C program, where there is a word called main, that is a function name. So in identifiers we have discussed. So identifiers are the names given to the various programming elements such as arrays, functions. So there we come across functions. That means function name we can call it as. One such identifier is this one, main. So actually identifiers means we can write on our own. So by just by following the rules. But in that case also we have two types of identifiers. One is inbuilt and another one is user defined. So inbuilt means one who developed the C programming software. So what all the function names or variable names he has written, same thing we have to use in case of inbuilt. Other than the inbuilt, what user defined identifiers are there, there we can create our own identifiers by just by following the rules. And if we observe this word main also, he has followed the identifier rules only. First character is not a digit and it is not a keyword, blank space is not used, underscore is allowed but it is not compulsory. If we want to use underscore symbol we can use, otherwise we can omit that underscore symbol, but other symbols we cannot use. So this also follows the identifier rule only. But when we write a C program, see, because this is an identifier, that doesn't mean that we can change this word, like writing capital letter M or MA underscore IN, like that we cannot change. We have to use it as it is. So all C programs, C++ programs will start executing. That means will start working from the main function. Okay. So whenever there is a function concept in a programming language, one has to give the control to that function, then only those functions starts working. So other than the main function, we will write our own functions. In functions chapter we will discuss that. So whenever there is a function concept in a C program, one has to give the control. So main function will give the control to the other functions what we write other than the main. But for main function, who will give the control, that is the question here. Operating system will give the control. So when operating system gives the control to the main function starts working. Starting of the function, that is execution starting is opening brace, ending is closing brace. Inside this, whatever the statements we write, it starts working. So in this particular function, so it just starts and it just ends. That means just to test it whether C program is working or not, C software is working or not, we can write this program. Okay. So when operating system gives the control to the main function, after all the task is done, again main function will give control back to the operating system. So this is about control part. Next part we will discuss in the next program, that is value part. When operating system gives the control and when main function returns back the control to the OS, it will return with the value also, that we will discuss in the next part.
Okay, thank you.
Okay.
Thank you.
Okay. So okay, Shrikant asked about application programs meaning here. So in when we call the software, so software is a set of programs as we know. So software is a set of programs written for a computer to do specific task. So whenever we consider any software, so it will perform some task. That means it will make the computer hardware to work. So that is the meaning. So when we consider the hardware system, without software, it's of no use. So best example we can consider is, if you can consider any electrical appliances, like if you consider the electric fan, okay, so without power supply it is waste. That means it will not rotate. It has the power to rotate, okay, it has the functionality to rotate, but without power supply it will not work. Similarly, in computer hardware system, if you consider monitor or keyboard, monitor is to display the things, but without software it will not display. So printer is to get the printout copies, but without software in that it will not do its work. So that means software is a set of instructions we are giving for the computer to do specific task. So we are telling computer hardware system to do some task. So in that we have two types of software: system software and application software. So main system software is OS. So system software means which is related to the system. Application software means, as the name itself tells, which is related to the applications. So which is related to the applications means somewhat related to the users. So that means application programs will be near to the users, whereas system programs are near to the computer hardware. Okay. So system programs or the system softwares or the softwares which are present in the like which we have installed in the computer system to do some task, and these system softwares will make the application softwares to work. Okay. So application softwares we can consider it as it is like user friendly, or it is near to the user, by which we can develop some applications. So we see apps in mobiles, those are developed by using application programs. Whereas if we see some softwares like disk cleanup, fragmentation, or some driver softwares, so these are all related to the computer system, and these are called as system software. Okay, so we will move further. Okay. So now we go to the basic structure of a C program. So before we start writing the C program, so let me open the hyperlink. Okay. So this is the basic structure of a C program. So when we write a C program, this much layers we can consider in C program. So first layer, documentation section. So if it is not visible properly, I'm reading out documentation section. So this documentation section means when we write a program, so if we are telling about that program, what the program does, or what is the aim of the program, what is the objective of this program, and what are the things comes in this program, when we write those things, those are nothing but comments. Okay. And these comments are not considered for execution. These comments are not considered for execution. So the name itself tells documentation. So for example, when we purchase any electronic product, they will give an small book, like booklet. So there we will come to know like how it works and all, how to use, like user manual, like that we can say when we write a program. So if I have written the program and if you people are looking at the program, you want to understand about that program, not completely but at least what is the aim of the program, or what it does, what are the things used in the program, then you can look at this documentation part, that is called comments. The name itself tells. Comments means what? Something we are explaining about that topic or about that subject or a object. Okay, that is nothing but a comment. Okay. Next, link section. So this is called as pre-processor statements. Okay. So in programs we will come across. I will explain in detail there. Next is definition section. So that means we are declaring the function. Next comes the global declaration section. So here especially we declare the variables. Okay. So by this time we came to know what are variables. Okay. Three definitions are there. Quantity, which will change its value, identifier which stores a value and which may change, or name given to the computer memory location where the value is stored and which will change. Okay, so these are the three definitions of variables. And when we start writing the variables, so in this section also we can write, in the main function also we can write. Okay, so there are two types of variable declaration, global and local. So in functions chapter we come across what are global variables and local variables, with examples also we can see. And whenever we use the variables, we have the topic called as data types. So data types is one chapter, there we discuss in detail how to declare the variable and all. Then comes the main function. So what we have written in this diagram, in this explanation, main function. Okay, so here we write the program statements. So in a C program we come across many, more than one function, not only main function, more than one function. In each function we will write the code. So again I will tell you about function in functions chapter. There is a chapter itself called as functions, they will discuss in detail. Right now what we do is, for writing a simple programs we will consider main function. Okay, in main function we write the program statements and main function starts executing, and main function itself is the first function to work. Okay, in C++, without main function other statements will not work. Okay, that means program execution starts from main function and program termination also happens at the main function. These are the two things. We look at this main function, opening brace, this main line with opening brace, this is the starting of the execution of a program, and the last closing brace, this is the ending of the execution of a program. So in that way we can consider. Okay, now next thing is sub program. That is other than the main function, what all the things we write, we can write after the main function. There can be more than one function. I said other than the main function also there can be more than one function. So they have written function 1, function 2, dot. That means we can write many functions. Okay, this is the basic structure of a C program. So before we go to this basic structure as well as, so 1 minute. So let us have little bit knowledge of algorithm and flowchart, which helps a lot for us. Okay, so because when we solve the problems by using computer, so that is real world problems by using computer. So what happens? We have to write the software for that. Okay, that means the usage or use of software itself solving the external problems, that is real world problems. Okay, if software doesn't solve the external problems or real world problems, then it's of no use. So software is nothing but set of programs. So that set of programs we write by using any of the programming language. Okay, so before we write the program, okay, that means before we develop the software, so we have to think about how to solve a program. Okay, so generally see, for example, if I say find the square root of a number by using program. Okay, so find the square root of a number by using program. So that is the problem what we have. So before we solve the problem we have many problem solving techniques. Like first thing is definition of a problem. That means we should know the correct definition of the problem. So sometimes you might have observed while writing exams in the final, that is in the question paper, sometimes we come across a wrong question. Okay, for that grace marks will be there, like that. So if the question itself is wrong, then we cannot solve the problem. Similarly in writing programs also, in solving the problems, real world problems, definition should be correct. That is what is the meaning of the problem. Next comes the analysis. Okay, we have to analyze the program. Okay, that means like what are the inputs to be given, what output we can expect, what is the logic we have to use, what formula we have to use. These are all comes under analysis. Okay, definition means question should be correct. If the question is wrong, we cannot solve the problem. Analysis means like inputs to be given, logic to be written, calculations to be done, formulas to be used, and what output we can expect from that program. Okay, next comes the design of the problem. Okay, so design in the sense here, we go for algorithm, okay, and flowchart. This is how we solve the problem before we write the program. So if we come across these things, it will be very easy for us to develop the software. So design means writing an algorithm and flowchart. See, this algorithm is nothing but I will tell you here, definition is there. Next comes the, after writing an algorithm and flowchart, we will go for coding. Okay, see, when the problem is defined directly, if we go for coding, it will be difficult. Okay, because nowadays we have started learning C, C++, Java programs directly, so we might feel somewhat difficult. There are languages called as algorithmic language only, that is analysis and design of algorithms. I think in B we come across this language, and there is also a language called as flowchart. Okay, so first what we do is we write the algorithm, and for that we write the flowchart. After writing the flowchart, coding becomes very easy. Okay, then comes the, after coding, so we can consider it as testing and debugging. Okay, that means how this program works, what output we are expecting, and what errors we are getting. Okay, those things comes under testing and debugging. Okay, next comes the documentation, sorry, maintenance. Okay, maintenance means if the customer tells I want this thing, the output, it all depends on the clients. Okay, so how they give us the task, we have to develop like it. Next thing comes the documentation. Okay, that means where we have to explain about that program, what it does and all, so that the other programmer or the user, if he look at the program, he should understand that. Okay, so these are the things which comes under problem solving techniques. Now what we do, we will just look at some part of algorithm and flowchart, then we can go for coding, so that it will be very easy. So now, so this is the algorithm. So that means it is a step-by-step procedure of a solution to a given problem. So some people say like step-by-step procedure of a problem. It's not a step-by-step procedure of a problem. Step-by-step procedure of a solution to a problem. Because algorithm is a solution, it is not a problem. Step-by-step procedure of a solution to a given problem. So what is that? What are the steps we will see? See, first step is start. Second, third, fourth steps are input, calculation, and display. So second step, third step, and fourth step can be many. It is not like only one input statement. Sometimes what happens, see, input statement can be zero input statement, zero calculation steps, and zero output statements. Directly we can go for stop statement. See what we've discussed in the previous section. Like if you look at this main program, only starting and ending is there. So as I said, there are no input statement, there are no calculation steps, and there is no output statement, directly end. So this means to test the program, we can write like this, starting and ending. Okay, that means in an algorithm, minimum requirement is start and stop. Then input can be more than one or more input statements, one or more calculation steps, one or more output statements. So, but if you consider one simple program with one input, one calculation steps, and one display statement, that is output statement, we can consider this start. Next step is input. So I have written some same meaning words like input, read, scan, get. So these things comes in the same meaning, that is input. So you can use the word input or read or scan or get. Next comes the compute or calculate or process or logic. So sometimes what happens, we will not use any formulas, but we will use some logic. So in conditional operator, we have tested it like using some logic, like 7 greater than 5, 7 colon 5. There is a logic, not a formula. There is a logic. So we have used greater than symbol, and we have written some logic there. So we have expected the output that is largest of two numbers. That is called a logic. So we can use the compute step, that is formulas, or we can use the some logic. Then comes the display or print or output. So three, within these three words we can use anything. Okay, then comes the last one is stop. Now when we design the flowchart, so we'll see what is flowchart. Flowchart is a graphical representation of a solution to a given problem. See, when we start writing programs, for every program I will not write algorithm and flowchart. Only for few programs I will write it. So I will tell you where it is required. Okay, so here flowchart means now it is a graphical representation of a solution to a given problem, or we can say graphical representation of an algorithm, we can say, because once we write the algorithm, we will come to know what are the steps required to solve the problem. By using that, by using those steps, if we design the graphical representation, then that we can call it as a flowchart. Graphical representation of a solution to a given problem, or graphical representation of an algorithm, we can say, because algorithm itself is a solution. So we will see here. See, same steps I have written: start, input, compute, output, and stop. So here, because it is graphical representation, we have symbols for every step. Okay, so for start we can consider it as like oval symbol. For input, parallelogram, input and output, you can see here input and output parallelogram. For compute calculations and all, rectangle symbol is there. And for the stop, so last one is stop. By mistake I written start there, it is a stop symbol. Okay, so there we have to write it as stop. So if you go for the so these are the symbols of flow chart. Okay, oval symbol, it is a start and stop. Okay, parallelogram to read, that is to input the values, and display, or we can say print. If there are any assignment statements, we use assignment operator like equal to. So, or if you have any formulas to be written, okay, so in this rectangle box we will write it. Then next comes the diamond symbol or plus symbol, decision making, that is to write the conditions. Okay, that means logic, some logic we will write it there. Out of that we can expect either the result as true or false. Okay, then comes the for loop. For is a keyword here, so we have the concept called as for loop, there we will discuss. So this symbol is used for loop. I think this is an hexagon. Okay, 6 sides are there. Next comes the arrow mark. See, this arrow mark indicates flow of control in a flow chart. Okay, see, when we consider the algorithm, the numbers, that is this step numbers itself indicates the flow of control. So there is a chapter called as control statements, there we will discuss in detail about the control. Right now, for time being, you remember, control means in algorithm it indicates the step numbers. Step 1 start, step 2 read, step 3 compute. So when I say step 1 start, step 2 read, that is the control. Okay, first control is step 1, second control is step 2, like that. When we go to the flow chart, the same control here it becomes, here we will not consider the steps. Instead of steps we will consider the arrow mark. So this arrow mark indicates the flow of control. So from start to input, from input to compute, so this arrow mark indicates the flow of control. So it can be right, left, or up, down, anything. So this indicates the flow of control in the flow chart. Okay, so when comes to program, so there F7 key we have to type, I will tell you. Okay, now people copy this algorithm concept flowchart, and we will go to the program. So if you have any doubts, you can ask. So when you consider the input, calculate, and display statements, you remember one thing: input statements can be one or more, calculation statements can be one or more, display statements can be one or more. But start and stop statements are only one.